Hello, everybody. I'm Tom Quinn with Broadcom Mainframe Software. So I'm the product management lead over our automation, performance, and optimization products. So that's a lot of the core products that Mike had talked about in another session. So that's our SysViews, our NetMaster, our OpsMVS, Mainframe Application Tuner, Mix. So these are all the core products that our customers are using every day. Joined by my colleague today.
Hello, everyone. This is Machindra Nail. You can call me Mac. I'm the solution architect working on the WatchTower platform.
So Mac and I are going to talk to you today about how we are expanding the value of our core products, right? So one of the situations that we have today is we have those core products are used by our domain experts. So an example of SysView, for example, it will use, or SysView monitors your CICS, your IMS, your MQ. You might have multiple people that use SysView, use that specific piece that they're interested in. They know you've got your network analysts, they're using NetMaster and so on. So when a problem does occur and they get that problem inside of their product or through an alerting system, they're looking at their domain tool and they're only seeing their domain. And so we recognize this as kind of a problem, right, to some degree. So what you end up with is that war room where everybody's looking at their own tool, everybody's pointing at each other. And one of the things I like to point out, I've got a long history of performance management myself. And one of the things that I thought was most important of not only finding where the problem is, it's finding where the problem's not, right? So I like to be able to say, not my fault. That's just me. So with WatchTower, and so with the observability platform that we've developed, we've integrated all of our products into the WatchTower capabilities that we offer. One of those capabilities we'll start with here is what we call Alert Insights. So when you see a problem, say in CICS, or you see that in MQ, you can generate an alert, but that alert is not just in that product anymore. You've now escalated that up into Alert Insights, which by itself may not sound all that interesting, right? It's like, okay, great, an alerting capability. Where it becomes interesting is Alert Insights will now look back to all those core domain products and pull information from the time of that alert and correlate that information together. So now you're not just seeing that CICS alert that maybe is interesting by itself, but what was happening in MQ at that time? What was happening in DB2? What was happening on the network? Like, is this a bigger problem or is it just this particular piece that I have? So we call that contextual insights. So to the alert that of itself, you're seeing the context of that alert. You're bringing in all the information from all these different domain products. Now, once you got to that point, you see the alert, you see what's happening, you see the context of what's happening. We can take that then to a next step, pulling in data from additional resources to get to dashboards.
All right. So let me start with some challenges what mainframe operation team today faces, and then we go about what we provide with the WatchTower dashboards. So the mainframe operation teams today faces the challenge with respect to accessing, analyzing, and visualizing the data across the siloed domains. So we have tools already which actually does this monitoring for DB2, tools for CICS monitoring, network monitoring, storage monitoring, but all these deep tools actually provides one domain view. But imagine, picture this, that if you are facing a challenge with the CICS, there may be a problem with the network, there may be a problem with the DB2. So we would like to actually bring all this data, siloed data together in one central place, right? So we want to actually see this data in near real time, and often the mainframe operation team want to see the historical data as well for trend analysis. That's where the WatchTower dashboard comes into picture. It taps on the existing Broadcom's monitor such as SysView, NetMaster, Vantage, SysView for DB2. These monitors for the last decade actually fine-tune the collectors. So we collect a lot of KPIs around CICS, DB2, MQ, IMS, network, TCP/IP stack, volume groups. All this collected telemetry data is being streamed to the WatchTower platform, and that's where the dashboard comes into picture to visualize. Now we catalog this particular telemetry data into our efficient data store and make it available to variety of personas, which includes the system operators as well as the subject matter experts who are trying to solve an incident on the mainframe. With the Watchtower dashboard, you're not starting fresh. We have baked in some templates which get you started immediately, and that's where our experts actually prepare those templates so that you get started right when you install the product. The dashboard correlates all the data from across the CICS, DB2, MQ network. You can imagine that you can build one dashboard which can cut across multiple domains and look from the application perspective. The dashboard has easy, intuitive way of building the custom dashboard if you want to. There is no query layer or nothing that you will be writing complex queries such as PromQL, but it is easy to pick the metric, pick the resource, and build the dashboard. Share with your team so that at the time of incident, all of you will be looking at this particular dashboard collaboratively and pinpointing where the problem could be.
How do your customers typically set their dashboards up? Is it around a workload? Is it around, do they have like several dashboards that are for different workloads that they need to keep their eyes on because their SLAs are so high for those? Or like how do they normally do
Or
it?
is it maybe set according to like the user and their priorities?
Absolutely. So the question was about it is by persona or is it by the application perspective? Both ways. So if I'm a CICS administrator, I would be responsible for upkeeping the CICS system. In that case, my view would be CICS dashboard only. Whereas if I'm looking from the application perspective, I'm not looking for the infrastructure. Perhaps I'm looking for the golden KPIs from the application perspective. In that case, whatever makes that application, which includes subsystems, I will put them together. So both ways you can create the custom dashboards.
How do you see your customers doing it?
Currently, the customers are focused more on the infrastructure side. So if you look at the screen, the CPU busy percentage, this particular chart, what we call it is a ML highway chart. There's a machine learning highway chart. This exactly does what you're talking about. That instead of me watching this particular matrix, the machine is watching this matrix and finding out if there are any anomalies in there. And that's why we call these an intelligent dashboard, because we embed the machine learning in the visualization. We bring the alert exceptions within the visualization. So you are looking at alerts, you are looking across the domain data, you are looking for embedded machine learning within the dashboard.
And so again, this is looking at the data that we're seeing, the dashboards that we're building out. This is extending the value of those core products that we have. So again, when you're looking at your SysViews, your NetMasters, Vantage, you're looking at your domain-specific data. We're utilizing that same data for multiple purposes. So it's not that you're installing, say, another product called WatchTower or WatchTower dashboards. You're installing this platform that's utilizing all the core data collection that's already occurring, which kind of segues into our machine learning piece. So with SysView, with NetMaster, Vantage, SysView for DB2, we're collecting that data. That's what our domain experts are using. We're also making it available external to those particular products into what we call our ML Insights. So our WatchTower ML Insights is our machine learning component, utilizing that core data collection. It's the same data. We're not installing another data collector to do all of this, right? We're utilizing that data that you're already getting, you're using on a regular basis. And this is, with my performance background, I can go into details with, static thresholds and dynamic thresholds, right? This is what we would call that dynamic thresholding. What is happening as it relates to, time? Like where, as a Monday morning is different than a Wednesday afternoon. And this is where this anomaly detection comes into play. And we'll look at your historical data, and then the real-time data is coming in. It's scored against that to determine, is there something different that's happening that's not normally happening right now? As opposed to a static threshold is the number's 5. Is it 5 or not? Is it above? Is it below? So the machine learning piece is really taking all that knowledge and applying it. Mac, you want to talk a little bit more about the machine learning?
Yeah, where do the rules come from? Are these supplied by you or by the end user?
Right. So I'll answer that. So you can imagine that the collectors that we have in the currently with the SysView, NetMaster, Vantage, all monitors collect huge amount of metric data, and then watching them, and then putting the thresholds. It's a hard job, isn't it? Your workload changes, your system changes, and henceforth the Monday mornings are different than the Friday afternoons, and so that means you will be keep actually playing around with those kind of threshold rules, and that it's not an efficient solution. So perhaps we need to shift from reactive to proactive approach, and that's what this machine learning does for us. So instead of you watching hundreds and thousands of like metrics across subsystems, the system will watch them, and then we employ the machine learning algorithms such as kernel density estimator, which is the customized algorithm to keep looking at the metric history, then give the probability or the predictions how this metric should behave in the future, and then overlay with the real metric on the top and see if there is abnormal behavior.
I think to answer Steve's question, you install this,
Yes.
it learns for a few weeks,
Right.
and then it sets some thresholds. Is that what you said, or is there something?
Well, it sounds like what he said was that these are like more dynamic than
Yes.
traditional thresholds, which is what I love about it.
So it'll learn based.
Yeah.
Yes.
So it'll learn based on your system.
Yes.
Right. It learns from your system. So as the more data it has, the more intelligent it gets, right? So as it experiences that first, in the United States, we have the Black Friday sales. Resources probably spike that day, right? So the next year, it's going to see that. It's going to recognize that, hey, we had a spike on this particular day, right? Or even on the Monday mornings when everybody's logging in from a long weekend into their brokerage accounts to see what they're going to do this week, right? That's maybe there's a peak there, but on a Wednesday afternoon, nobody does that, so it's low. So you're building out these bands of normal activity, and as a new real-time data comes in, it's looked at to that band of normal activity,
Right.
and then it will see where does it land? Is it within that band, or is it way outside? And the farther outside of that band of normal is the more severe the alert. But what's nice about this too is you also start to see slow creeps, right? So we'll hide those from you a little bit at first, but then once that slow creep continues, we'll let you know about it. And so this is where there's that good tie between your static thresholds and your dynamic thresholds. So a lot of people think of static thresholds as being like, these are my SLAs, right? These are my agreed upon performance profiles for this CICS transaction, for example. But I could be running, let's say it's 5. I'm just going to make up numbers here. It could be 5. We're always running at 2. We go up to 3. I still don't know about it. Machine learning will know about it. It'll start to see that slow creep. It goes from 2 to 3 to 4. It's going to tell you about it because you're outside of normal. Your normal is way below your SLA. It's not a problem. But if you bought yourself 2 hours on the clock to see that slow creep before it gets to be a problem, that's great, right? And so that's one of the other side advantages of machine learning is you're buying time on the clock. You're getting to know about a problem, a potential problem, long before it ever is.
So it only does reactive. It doesn't make any decisions. All it does is inform you and say, hey, there's a slow creep going on.
So you could build in automation. So there is opportunity to build in automation when it detects an anomaly far enough that it would want to create an alert. That alert can have automation tied to it. So if you did want to, like if it's a common problem, can't think of one off the top of my head, add storage or something, or cancel a transaction. Like you could add automation to those tasks or to those alerts if you wanted to.
I feel like I at least am swimming in the deep end of the pool here, because you're describing a reinforcement loop of some kind, right? But you're not explaining what is there a human? Are you learning from human interaction? So I assume this model comes in with a baseline.
Yes.
Right? So that's the first thing. Where does the baseline come from? You have an opportunity, like most vendors do, to consolidate typical behaviors and have a human say, just use typical behaviors for this industry or for that industry or for this application or that. That can establish a baseline. But then you need a reinforcement loop in order to determine for the particular application and scenario, what is normal and what isn't. I love that it's learning, and I love that it's using ML to do so. You haven't described a human intervention there. So in other words, like Stephen, what we're imagining is the operator sitting there and gets an alert, or Jeffrey, and says, oh, this is out of band. The alert says, this is out of band, and the operator says, no, it's not. This is normal. And after 3 months of that, or well, almost immediately, they may not get that alert anymore. That's the behavior you're describing. Is that right? I feel like I'm filling in blanks here. I want you to fill in.
Sure. So I'll help you with that. So the two questions that you asked about, where's the baseline coming from, and is there any feedback loop involved in the machine learning? So the baseline, when we ship the product to the customer, the baseline gets automatically built for that customer. The models will be built for that customer. There is no model that we ship to customers. As the data comes in, we look at the history, and the model gets built for that particular metric and resource on the fly. And that's the model that will keep changing as the metric behavior changes.
Yeah, okay, yeah,
right?
of course. All right,
yeah,
good.
so that's the baseline
number one.
Number one. And number two is the feedback that we don't have yet. It's on the possible roadmap that we are looking for the feedback from the customer. So today, when the ML alert comes in, it may be possible that the operator look at it and says, maybe it is not an issue. For that, today we ask the operator to go and change the monitoring rule, which involves the machine learning, and adjust that, which we could do automatically.
But that is human. I would argue that is human feedback.
Yes.
I described a method of human feedback, but you're saying like the alert comes in, and then the operator's action is actually changing a rule that changes the alerting process.
That's right.
So that's all right. Good.
Yes.
Can I ask a slightly more prosaic question? You talked about the learning exercise that the tool will go through to give you the necessary historical data, then to provide a heat map of like, well, this is what normal looks like.
Right.
But you've also mentioned like there are going to be particular moments in the day or the week or even the year. Is your suggestion, or is your sort of operation to go back at least a year to provide that? Because I can think of Black Friday, Christmas, end of year reporting, all of that kind of fun stuff creates anomalous performance metrics that you need to learn from, right? Is that basically how you're doing it, going that far back?
Yeah, so currently what we do is that we learn the cyclic behavior. That's an important part. So the seasonality, cyclic behavior is already taken care by the algorithm. So with the aggregated data, you should be able to correlate from the past event to the current event. That's possible.
Yeah, okay. So the customer's like, they have that data anyway, right? So there's no big deal just to go back however far back in time, but
That's right.
You're going back quite a long way though to create that model.
Yep. Right. Excellent questions. Thank you.
So this is like a diagnostic machine learning application.
Diagnostic machine learning. Can you expand a little bit on what you mean by that?
So it just it's basically everything that you've been saying. It can go and it can look at all of the different sources, bring those all together, and then say, oh, here's where the problem was. Diagnose where the problem is.
Yes, right, yes.
Or is it just alerting you to the problem?
A little bit of both, right? So the machine learning component is going to alert you to a potential problem, right? So there is a change in normal, right? So that's your alerting piece of it. Something is different than normal. From a diagnostics perspective, with building out the dashboards, if you put that, what we call the ML highway, so the machine learning, the historical piece of that view of the data, that can help with the diagnostics.
So the diagnostic still has to come from the human.
Right.
Right,
So you have multiple
it's
sources.
basically just giving you the,
Giving you the-
here's what we see, he's reporting on it.
Right.
Okay.
It's visualization.
Yes. Yep. All right, great questions, thank you. That tooling for their workflows to see the data from multiple sources and find that root cause of the problem more quickly, do some collaboration and get to the root of the problem. So,
Quick question, how well do you play with other tools? Because a lot of mainframe sites might not have the complete suite. I might have a bit of a mixed bag from some of the other vendors. So can we ingest data from other vendors? Do you have an API where I could push stuff to you?
So long term, through the usage of open telemetry, that may become more possible. right? So if you can get the data out in an open telemetry format, your different signals, that may be something that we would pull in.
Can you comment a little bit on the data integration here from disparate sources? Because that's the 50% of machine learning that seems to be talked about 5% of the time is data quality and curation. So how are you accomplishing that? Since the more disparate sources you have, the better the alerting.
Right. So the way that currently we work is that these collectors on the host on the mainframe, they are now collecting the data at the tune of say 1 minute interval, and then you can change that interval if you will. And our collectors now talking in the same vocabulary, so that the semantic convention of the resources remains the same. And henceforth, the machine learning does not have to think through that these are disparate sources, but it is one source like SysView for DB2 and network, they are going to talk in the same semantic convention. So that means if you are collecting data for a GUI system, another collector doesn't say that it is not a GUI system, but it is a host. Both are saying it is a GUI system. So we should be able to correlate this in the machine learning.
It's a generative model so that it's taking this stream and predicting what's coming?
No, so we took care of the data collection speaking in the same language. It's not a generative model.
Yeah, I got that.
And once we collect this data, then we know that this is the sysplex, this is the GUI system, this is what the network stack. For the same sysplex, for the same GUI system, this is the CICS region. So you see that there's a common vocabulary between these two that we are leveraging within the machine learning. But there is no LLM or generative model which brings the semantic solutions on the top.
Is there any plans for automation, recommendations for next best action? I've done this thing 9 times, on the 10th time automate it. Can I build that level of automation based off the alerts?
So this ML alerts, which actually has got integration with the Broadcom's Ops MVS, which is our event automation platform. So that solution with the integrations from the ML Insights or integrations from SysView and other monitor products, you can actually write some sophisticated event rules to do some automation, deduplication. So you have to do that manually for sure. When we talked with the customers, the reaction was that I don't want your observability platform to take the action to cancel my important CICS transaction. Let me, human, be in the loop. Let me write the event, and so that I know what I'm trying to do. In order to take that action, typically they have got a service management and then incident and all these policies in place in order to get something done. So we make sure that the contextual information is provided, event automation hook is provided, and then it is up to the customer to go write that rule for them.
Okay.
So it could come back with reactions. Do this, you can do this, you can do this, and then have somebody make a decision.
Right.
Okay. I do have one more question, and that is somebody that actually, let's say they're implementing this into the system. Does it backlog? Does it monitor or plan and monitor? So let's say that somebody's been running their mainframe for years now, and then all of a sudden they install this WatchTower software. Will it be able to go back and look at the data and say, hey, on every year on September 11th, this happens. Every year, these are the dips and these are the peaks of things. Does it build up so it can create a model going forward?
So currently we don't have the ability to go look at the historical data that you may be having in a different format and then preload in the model. But rather, at this moment, when you deploy the application and it starts stemming from the SysViews and NetMaster and other products, that's where it starts building the model then onwards. Okay. So it's a real time, and when you get installed, that's where it starts.